Dear all of my students for the class CMB 343 Computer Security Principle. Let's go today with each other with the chapter 2 as a second part for the elementary cryptography. At the first part of this chapter, we end up by the symmetric encryption technique. We end up by what we call security mechanisms, which is used for encryption and decryption and authentication. That security mechanism have symmetric algorithm and asymmetric algorithm. Let's go back. Symmetric algorithm, it means that you are using single key used for encryption and decryption. Shared secret key between the source and destination to encrypt at the source and decrypt at the destination. The second part here, which is asymmetric encryption technique or asymmetric algorithm. For that type of algorithm, we call this is public key encryption technique, which is here as a public key encryption algorithm. That public key, we will see with each other that it used two keys, one as a public key and one as a private key. We will see with each other how that key is used and which one used for encryption and which one is used for decryption. Let's go step by step with each other. That the outline for this part as elementary cryptography, we have the public key. We will go in details. The use of encryption, how to encrypt and decrypt using public key encryption techniques. And then how to make use the hash function. And we will see how the different hash function. And then we will see how to make use the public key encryption technique for digital signature and for the certificate. Then this is the outline for this elementary cryptography chapter 2. Let's start here. When we say public key encryption, and the public key encryption technique, asymmetric algorithm, it means that the public key encryption technique use asymmetric technique. That asymmetric technique, one key to encrypt, another one to decrypt. It means that each user have two keys, which is here. That two keys is a public key for encryption, widely and openly distributed. It means that that public key is distributed for the all user in the network, which is used for encryption. It means that if I would like to send a message to you, I will make use your public key, which is distributed over the network, and then send the message to you using encryption by your public key. What does it mean? No one on the network receiving that message can decrypt that message except the destination, which I send to him, because he is the only one have the private key of that public key, which is used for decryption, which is here, private key for decryption and signature. Let's go here, private key for decryption. It means that when I send a message encrypted using your public key, no one around can decrypt that message except you, because you are the only one, the only holder can decrypt what has been encrypted under public key, because you are the only one have the private key of that public key. Then for the public key encryption technique as an asymmetric algorithm, this is two keys, one public key and one private key. The public key is distributed and published through the network, used for encryption, and the private key is a private, owned by only you, which is used for decryption. Later we will talk about how it is used for signature. Address problem of key distribution and management with symmetric secret key system. If we go back for the symmetric encryption technique, it means share the secret key between the source and destination. Then the source and destination have the same key. Then how we can distribute that key between the source and destination? If you are in the local area with each other, then it can be easy. But if you are here and your friend in a far east, then how to distribute, how to send that key as a secret key, shared secret key, to your friend at the destination to decrypt the message. The problem here can be solved using the public key encryption technique, because address problem of key distribution and management with symmetric secret key system. Then the public key encryption technique used for key distribution of the secret key between the source and destination. If we continue here for the requirement for the public key encryption, one of the keys must be kept secret, yes, which we call private key. That private key is the secret for the owner of that key. Impossible, at least impractical, to decipher message if no other information is available. Knowledge of algorithm, one of the keys, and sample of the ciphertext must be insufficient to determine the other key. Then we can say that it's too hard to get. If you know one key and part of the ciphertext, sample of the ciphertext, it is insufficient to determine the other key. This is one of the main requirements of the public key encryption technique to be complicated for the attacker from outside. Let's go here. When you go with the public key crypto system, then the concept of the public key is coming by Diffie-Hellman in 1976, and Raivis Shamir Adleman have described the public key system in 1978. Then many proposal is coming, and then we end up by the serious candidate public domain, which is RSA, Raivis Shamir Adleman public key algorithm, and El-Gamal algorithm, which is the new algorithm as a public key encryption technique invented by the man who is El-Gamal. This is the name of the inventor. Looks like here Raivis Shamir Adleman. This is the name of the inventor of that algorithm, also El-Gamal algorithm. When you go with the Raivis Shamir Adleman here as a encryption decryption, encryption by exponentiation, it means that the ciphertext is equal to the plain text to the power of the encryption algorithm. E here, it's the encryption algorithm. The exponent E is encryption key. This is the encryption key, sorry. The E is the encryption key, which is exponent E is encryption key. The corresponding exponent D is for decryption. D here is the private key. Then this is the encryption part. The ciphertext is equal to the plain text exponent of E as a public key, which we said this is distributed through everyone in the network. And the decryption here, the plain text is coming from the ciphertext to the power D. D here is the private key. No one have that private key except you, because you are the owner of this one. Computation preferred in a finite field using modular arithmetic. It means that in the public key encryption technique depend on mathematical calculation, modular arithmetic, which is modular arithmetic. On the other side, in the symmetric encryption technique, there is no mathematical calculation. It depends on permutation and shuffling and rearrange position of the character. But here, it's depend on the mathematical calculation on the modular arithmetic. Based on the problem of factorizing large number in a finite field, it means that the key which is D and E is coming from modulo arithmetic of the prime number, which is B and Q. Prime number is a two large prime number, B and Q. Then B minus 1, Q minus 1 is equal N, which is modulo arithmetic. N here is very hard for factorization. Then to factorize, again, is the attacker from outside. It needs time consuming and no known shortcut. It means that it's too hard for the attacker from outside to analyze the algorithm, the key. When you go here, RSA, which is used for encryption and the digital signature. And it means that one of the applications of the RSA used for encryption and digital signature, which is here as a block diagram. This is the plain text of the user Alice, and this is the destination or the receiver, which is Bob. Then Alice would like to send a message to Bob. Then the first step here under the encryption and the signature, then encrypt the message using the private key of Alice. Then the source Alice use the private key of himself to sign the message, and then the signed message will be encrypted using the Bob, which is the receiver side, public key. Then now the message here, which is encrypted signed plain text. Then the output here will be a message which is signed and encrypted as the title here. When it goes to the destination at Bob here, the block diagram showed that then you have here public key for encryption. Then at that block here, use the private key of the destination Bob for decryption. Then now the message here is only signed. To verify the signature, you will use the public key of the private key used for encryption here to verify. This is mean that authentication, that this message is coming from Alice by this signature of the private key. Then this block diagram shows that the RSA encryption and signature. When you go here as a characteristic of public key encryption, it's more complicated against the attack from outside. But as we may said before, that as much as you have a complication, as much as degrading the performance of the system. That's why the system will be very slow relative to the symmetric encryption technique by the factor of 10,000 or more. Mean that you increase the security, the complication of the security, but you degrading the performance of the system. Because here we are using a large key. As an example, for the symmetric encryption technique, data encryption standard, you are using 56-bit for key for encryption decryption. Here the key can be 500, 1000, 2000 bit or longer. Then as much as you increase the key length, as much as the complexity, as much as you are using more complicated algorithm, as increasing the complexity of the encryption, but at the same time you degrading the performance of the system. If you come here, finally we have a comparison between the secret key with the symmetric encryption technique and asymmetric encryption technique. That the table here show that comparison between secret key symmetric encryption technique, public key asymmetric encryption technique. Then protection of the key must be kept secret, one published and one kept secret. And best use, key distribution, speed. We see here this is very far speed here. This is low speed here, degrading the performance of the system. This is used for the key distribution. Public key is used for key distribution. But here, if you would like to distribute the key, then you have to use over a secret channel mostly often. Then this is the table comparison for